I thought for my next video I'd build up a kit from QRP Guys called the Lidia, and I'll include a link below to that kit. Unfortunately, they only sell the board these days, so they don't sell the complete kit, and I believe the board's available for around about $10. The original design for this came from a Polish ham, SB5DDJ, who's now HF5WIM, and I'll include the link to below to his homepage where he describes the receiver itself. The design is interesting in that it uses an MC3361 Narrowband FM IF IC in the role of a direct conversion mixer. I've got an internal diagram of the MC3361 right here, so you can see what's being used in this kit. And all of the FM demodulator circuitry is not used. We've got some squelching here that's not used. Basically, the RF signal comes in here. It gets mixed with a local oscillator here, which is at the receive frequency. It's a direct conversion receiver. And then the mix product output gets directly sent from pin 3 here to pin 10. So you can see here, pin 3 to pin 10. And it goes through some further filtering. And you can see that's controlled here on this part of the circuit here. And then finally, pin 11 is the audio output, and that audio output gets sent through an audio amplifier through to your speakers or headphones or whatever. Now, one of the things I don't quite understand just yet is how this circuit achieves unwanted sideband suppression. Perhaps it doesn't. Perhaps it outputs a double sideband there. I'm not sure entirely, but I don't see anything here which would suppress that unwanted sideband. Perhaps it doesn't. We'll find out together. So onto the circuit itself and the order of construction. I'll do it module by module as I usually do. First, I'll start with the power supply. Then I'll move on to the bandpass filter and preamp. Now this preamp's optional. You can bypass it by basically connecting this jumper right here. Moving on next to the audio amplifier here, and that's based around LM386, kind of a similar configuration. You've got a volume control right here, and then audio out comes out here. Parts 4 and 5 are the tuner components, and that consists of a number of capacitors, an inductor, and then these varactors that are controlled by the tuning pot right here. 5 is the MC3361 itself, and some of the associated circuitry with that. And then finally, this portion here is the output to the optional frequency counter. So you'll get a signal out here that basically is the current direct conversion LO frequency. So I'll get on with that, starting with the power supply. I'll do the usual sort of build by build, module by module, test each module, and we'll see where we get to. Okay, so that's the power supply circuitry built up here. Obviously, you've got to know the orientation of the electrolytics, so the negatives to the top in both these cases. We've got a diode down here, and the stripe is, or the cathode's to the bottom. And then the other two 100 nanofarad caps. Actually, they didn't come in the kit. I had to supply them myself. They did have 10 nanofarad caps in there, and I'm sure they could be substituted. But anyway, let's test some voltages. So first one to test is the 8 volts. So that's convenient spots right there. Turn the switch on, and there you can see a little bit low, 7.8 volts. So that confirms the regulator right here is working fine. And now to test the 12 volt supply, that's at R13 right here. You can see the caps are discharging there, but let's turn the power on. And there you can see 11.7 volts, which is good. So that confirms the power supply is installed correctly. And we can move on. Okay, so the next part I'm going to install is the bandpass filter here and the JFET-based preamp right here. And like I said before, that's actually optional through this jumper lead right here. So once I've got this installed, I'll be able to inject the signal here and this should be a bandpass at 40 meters, so we should see attenuation outside of that. And then I'll have a look at the output both with this FET in circuit and with it out of circuit. So I'll get that installed and then we'll do some testing. Okay, so I've installed the bandpass filter, but there's a problem. I'm getting probably 40 or 50 dBs of attenuation through it, even at the pass band. I'll pause it here. I've actually found what the problem is, but I'll let you look at this for a moment. All right, here's the problem right here. I've got these capacitors installed the wrong way. So these capacitors should go across here, not vertically like that. So I'll reinstall those capacitors and we'll come back and do some testing. Okay, so I've put those caps back in, this time the right way, and this time the bandpass filter is working correctly. But let's have a look at that on the oscilloscope. Just panning up there. So we're right at the edge of the band there at 6 megahertz. Let's go up to 7 megahertz. You can see there now we're at 7 megahertz. And let's trawl around. So let's go up to 7.1, 7.2. And now we're about 7.4 megahertz and it's starting to tail off there. Let's see on the lower side. So already at 7 megahertz, it's starting to go down. And interestingly, there's actually a peak around 5 megahertz too. So you can see it's popping up there at 5 megahertz too. Interestingly, even higher peak. So what we'll do is let's get that on the spectrum analyzer and see what it looks like there. Okay, so here's that signal on the spectrum analyzer. You can see there's the two well-defined peaks there. I've got a peak at around about 1.5 megahertz, and then the other peak, whoops. So there's 1.5 megahertz, and then the other peak is at roughly 7.168 megahertz. So interesting structure there, sort of a dual-peaked bandpass filter there. Anyway, let's move on to the next part. So the next part is this optional preamp here, which the author says is not necessary at 40 meters. I'll get it installed anyway, and then we can measure and see what difference it makes with it off and with it in circuit and with it out of circuit. So I've just installed the JFET, the preamp, and something definitely unusual is going on here. As you can see, it looks like it's acting as some kind of oscillator rather than amplifying the signal. What I might do is replace that FET and see if I've got plenty of J310s around. I'll replace the JFET and see if I get any improvement. Okay, so I've swapped that JFET with another one, and really it's unchanged. You can see here that primary signal is at 7 megahertz, but underneath it there's all this oscillations or harmonics or something going on in the signal. So now that's with the interesting. Let me just turn around, stop off. So that's with the with that jumper completely out. If I put the jumper in, you can see no problem at all on the signal there. So it's kind of interesting putting that JFET in there. I mean, obviously, if you have a look at the way I'm testing this, I've got sort of wires running everywhere. I mean, they are twisted, but I guess I could be picking up some RF on the output there or something. But anyway, what I'll do is I'll keep moving on. Next section of the build is the audio amplifier. So just moving down to that. And this is a pretty simple section. What I'll do is I'll get the audio amplifier together and then do the usual test of you just put a probe against pin 2 of the LM386 and you should hear a hum from the speaker. So I'll pull all this together and we'll come back and do some testing. Okay, so the audio amplifier is all installed and ready to test. Obviously there's the observe the orientation of the LM386 here with a notch to the top. The rest of it's pretty straightforward. Again, you know, in the kit, I was only supplied 10 nanofarad caps everywhere, and the schematic says 100 nanofarad caps. They're just decoupling caps, so I don't think that will matter a whole lot. I just use the 10 nanofarad caps in there. But the way we test the audio amplifier is I've got it hooked up to my speakers, and you just probe the input, which is pin 2. Let me be quiet for a moment. There you go. There's that nice 120 hertz signal from this acting as an antenna and being amplified through. So that confirms the audio amplifier section is all installed correctly, and we can move on to the next step. And the next step is the mixer and the tuner section. There's no real point in installing these, sort of testing them separately. This tuning section needs the MC3361 in order to do the oscillation, so you can't really do anything without the without both of these in circuit. So what I'll do is I'll get all this installed, and then we can do some testing where we'll inject a signal in here, and we should probe the output here. We should actually see some activity on the output here. So anyway, I'll get all this installed, and we'll come right back. Before I go any further, I'm going to install these little brackets here in the front plate. It would be kind of impossible later on to install that if I don't do that, because there's a lot of space taken up by this variable resistor here, which is used as your tuning control. So I'll get that installed. It's a pretty simple matter. The usual, this sort of build we've seen elsewhere. You sort of put a bead of solder right down here, and then you hold that in place and put your soldering iron to it. So it's just a little bit fiddly, but pretty straightforward. Anyway, I'll do that before proceeding. Well, that was a little bit fiddly, but not too bad. You just have to get the orientation of these right. There's tabs marked A and B here. You just have to align those, and then you put a bead of solder on before you place it, and then get them together and run your soldering iron across it. The solder flows pretty easily. But anyway, that's that done, so I can get on with the rest of the build here. Just one note, the kit comes with, if you'll have a look here, right here, let me just make sure I got it in focus here. So the kit supplies these two diodes here, the Varactors D2 and D3. D4 is a placeholder for experimentation, and that doesn't come with the kit. So you get D2 and D1, D2 and D3, you don't get D4 in the kit. Anyway, I'll build up the rest of the tuning circuit and come back. Quick progress update here. Everything's going okay. The one exception is looks like I've misplaced this 47K trim pot right here, so I'm going to have to replace it with this. I don't have any of this type, so I'm going to have to replace it with a multi-turn 50K trim pot that I have right here. So anyway, things progressing okay. Just a few build notes. Obviously, these are the two Varactors right here, so mind the orientation of those. The flat spot faces out this way, or rather the wide flat spot faces out this way. And that's really all to note. Note the orientation. This is a 10 picofarad trimmer here as well. And then there should actually be 3 of these trim pots. There's 247K, and then there's a 500 ohm. So make sure you get the 47K over here, and the 500 ohm goes over this side. Anyway, that's just a progress update. So there's L3 wound. It's the only toroid in the kit. 29 turns on a T37-2. Let's just put that on the LCR meter and see what inductance is actually there. Be a bit of fun. Let's take up the frequency a little bit. So 3.49 microhenries, and it doesn't actually say what it's supposed to be in the kit, but that's 29 turns. We'll put that in, and we'll proceed from there. Okay, so there's the toroid installed right there. It's always good to to check continuity on the toroids. I've just got to see where that is now. And I should have continuity. Bear with me here for a moment. I should have continuity between here and here. That's where the toroid goes, here and here. And that's, so that proves that the toroid is all stripped and installed. Getting close to completed here. We'll move on to the installing the IC next, and then we're probably ready to test. Okay, so the MC3361, the mixer and local oscillator, and the tuning circuits all installed. Just a few notes on the install. There wasn't a 56 picofarad cap in the kit. Fortunately, I did have some available. There was a 5 picofarad cap in the kit. I mean, obviously, all this affects the kind of local oscillator frequency. So I could have installed that 5 picofarad cap and see what happens, but I thought I'd stick to the schematic, install the 56 picofarad cap. The other thing is these two caps here, 0.1 microfarad caps here, the kit doesn't have any 0.1 microfarad caps. It does have 0.01 microfarad caps, and I guess they intend you to install the 0.01 microfarad caps in the place. So I had some 0.1 microfarad caps in stock, so I just installed them there and there. So what I'm ready to do now is actually test the output, and the test point that I'm going to use is right at the gate of this FET over here. So this should be the local oscillator frequency right here. And so what I'll do is I'll hook this up to the oscilloscope, probe that. Now, we'll probably have to adjust, there's 3 adjustment points for the kind of the width of the bandwidth and where it actually is. And that's these two 47K variable resistors here and this 10 picofarad variable cap here. So I'll probably have to fiddle around with these a bit to get the sweet spot where I want it. So obviously the bottom end of this, I'd like to be around 7 megahertz. So what I'll do is I'll play around with that a bit, and then I'll come back and we'll probe against here on the oscilloscope. Okay, so I'm going to be probing right here at the gate of this FET. So this piece of circuitry here just provides a sort of a little buffer amplifier out to the frequency counter, which is right here. So I probably will install all this next and then just see what it is. But I can probe the gate of this now, and I should be able to see the local oscillator frequency. So, whoop, probing the wrong thing. Bear with. There we go. So let's pan up to the oscilloscope, and we can see that local oscillator frequency there. So you can see that it's around about 6.95. That's right at the bottom of the scale there. Let me raise it up a little bit. And you can see the, there we go, we're going up now around about 7.045 megahertz. It's still stabilizing there, 7.053. So let's key that into, I've got it hooked up to the signal generator, 7.053 megahertz. And then let's turn the volume up. And we can adjust it. Turn that up a little bit. Pretty quiet. Let me increase the signal generator. Let's say 30 dBm. And there we go. So there's so the signal generator is 7.053. And there's the 0 beat there. And I guess I've answered my question from before about whether this, how does it suppress the unwanted sideband? The answer is it doesn't. So there's the upper sideband. And there is the lower sideband. All right, so that basically confirms that I'm receiving This is at minus 30 dBm, so that's a pretty strong signal. If I go down to minus 50 dBm, you can still hear the signal. So cool. What I'll do next is I'll install the FET that acts as the buffer amplifier to the frequency counter, and we'll come back.
Come on back to Melissa, that's all right. It's usually good to get that call in. Oh, I don't know, I just do it. That's my bad. A W5RIM Julius P. Solid. Big fat girls in the back. I give them a big hug and I enjoy that. When did you start hugging people? Oh,
So as you can see, that's the receiver on the air. That's a fairly strong signal, around 7.18 megahertz. Bunch of guys there having a QSO. It's good to hear in the morning. The band, this is on 40 meters, and the band's starting to dissipate a little bit. So this is probably the only receiver I'm going to get at least today. So as I mentioned in the previous section, this receiver is indeed a double sideband receiver. So there is no unwanted sideband suppression, which is what I suspected. There didn't seem to be anything in the circuit to do that. I can't quite figure out there's that CW SSB switch that's in there, and I thought its function was to change the audio bandwidth, but it doesn't appear to do that. Let me just turn up the volume of it. You can hear it. And all it seems to do is, that's a local AM channel that you can hear now. So I'm really not sure what the purpose of that is. It doesn't seem to perform the function that I thought it would perform. Hang on a sec. Let me just turn that down a little bit. So I might play around with that a little bit more. I mean, this was a fun little kit. I always like building these little kits. You learn something in every kit. And this one's no exception. So anyway, I enjoyed this build. There is I did get a frequency counter module that I could put in there, and I did mount this on a piece of PCB. I'll probably save the frequency counter module for a different kit. So this is probably going to be a wrap for now, and hope you enjoyed the video.